Hello, good morning friends. Let us continue our first chapter regarding to 18 EE 304 third semester electrical and electronics measuring instruments. The first chapter, the basic of measuring instruments. Previously we have covered 3 classes, and at the same time yesterday also we covered one class regarding to the basic measuring instruments. Today we are going to learn errors in measuring instruments. Let us introduce myself. My name is Dr. C.H. Yadaya, Senior Lecturer in Electrical and Electronics Engineering at God Polytechnic, Usnabad. Let us recall what we have seen previous classes. We had discussed few terms regarding to measuring instruments, electrical measuring instruments, that are what do you mean by the measurand. The measurand is nothing but variable being measured. Accuracy. What is mean by the accuracy? Which an instrument reading approaches the true value of a variable being measured. Accuracy means which an instrument reading approaches the true value of variable being measured. What are the variable we are going to measure? That should be nearly true value. And precision. It is the measure of the consistency of a reproducibility of an measurement. Precision means if it is a measure of the consistency of reproducibility of the measurement. That means if you are taking the reading after 1 hour, if you are taking the another reading after 1 hour, if you are taking the another reading, this reading should be nearly equal and same. That means for the same atmosphere conditions, same instruments, same variable, you are measuring in a time frames. Whether you are going to measure yourself, or you are going to measure, or it may be measured by the some other person, or it may be measured by the some other any machine, but the value which is to be measured should be approximately true value and equal value. That is a precision. Sensitivity, change in output of the instrument for a unit change in input variable. If changes any input value, automatically the output correspondingly it has to change. That is sensitivity. Resolution, it is the smallest change in a measurand, a measured variable to which the instrument will respond. Resolution means if smallest thing changes, automatically it has to detect, it has to identify. And error, it is a deviation of the measured value from the true value of a quantity to be measured. Error means actual value minus measured value, that should be nearly 0. That is a error. If not 0, it may be error. If 0, it is a accuracy. So these terms already we covered. What do you mean by the measurand, accuracy, precision, sensitivity, resolution, error, range? These all terms already we covered. At the same time, we classified the instruments based on It's the analog instruments and digital instruments. What do you mean by the analog instruments? The instrument information is translated into a electronic pulse of varying amplitude is known as the analog instruments. Information is translated into a electric pulses of varying amplitude. Amplitude may be from 0 to 1, 0.1, 0.2, 0.3, 0.4 up to 1. So, this is the in between, that is analog instruments. Whereas the digital instruments, the information is to be transformed or translated into a binary format where each bit is represented of two digits. One is the 0, another is the 1. Binary instruments, that means digital instruments, whether it is the reader 0 or 1. All machines works on digital instruments only. And at the same time, we further classified the electrical measuring instruments, classified based on its principle, based on the moving iron instruments and moving coil instruments, the induction type instruments, hot wire instruments, dynamometer type instruments and electrostatic type instruments. These are the principles of energies. So, here the moving iron instruments further classified into attraction type instruments, repulsion type instruments, and moving coil instruments, the permanent magnet instrument and electromagnet instruments. Whereas the moving coil instruments are only for DC measurement purpose, whereas the induction type instruments are AC instruments. Remaining all can be used for both purposes. And at the same time, so what are the effects on an energies is required to develop a deflection torque? That is a magnetic effect, magnetic induction effect, electrodynamic effect, thermal effect, chemical effect, electrostatic effect and Hall effect. These are the input sources to develop a deflecting torque that may move the pointer from initial position to final position. So, magnetic effect can be used for voltmeter, ammeter, wattmeters. Magnetic induction type can be used, induction means the AC purpose only. So, where we can use for manufacturing of voltmeter, ammeters, wattmeters and energy meter also. And whereas the electrodynamic meters, we can use voltmeters and ammeters and wattmeters. Whereas the thermal effects can be measured only ampere hour meters. It can be used for a DC. And whereas the chemical effect, it can be used in case of the some instruments. And electrostatic instruments can be used only for voltmeters. And whereas the all effect type of instruments are generally used to measure manufacturing of the flux meters. It measure the what is the magnetic field at a place that can be measured using the flux meters. This is a different type of the energy sources and principles. Based on these principles, we are going to manufacturing our electrical instruments, the voltmeters, ammeters, wattmeters, energy meters, flux meters and power factor meters, different type of the meters generally we can use in our field. Now, we can also classify this basically instruments based on method of measuring, whether you are going to use these instruments are absolute instruments or secondary instruments. One is the absolute instrument, another is the secondary instruments. The secondary instruments further classified into the indicating instruments, recording instruments and integrating instruments we have seen. Now, what is the main difference between the absolute instrument and the secondary instruments? As we know that absolute instruments are the very standard instruments and it gives the quantity in terms of the meter constant and deflection, and but it is a very costly instrument, and so it can be used very rare, and we can use where we require the very important precision readings is required, that is a research and development labs. And what are the examples? There is a tangent galvanometer and a Rayleigh's current balancing instrument is an example for the absolute instruments. Whereas coming to the second instruments, it is a substandard instruments. Nowadays 90% of the instruments are used in our day-to-day life in the second instruments. Directly it will give the deflection reading, no need of multiplication of MF, and these are the instruments are very cheap and best and rugged also, and these are very widely used instruments. These instruments are calibrated at initially with help of the absolute instruments, whereas in case of the absolute instruments, the deflection into multiplication factor has to be multiplied and it will take some reading to finalize, whereas in second instruments instantly it will give the what is the value by deflecting on a calibrated scale. This all we covered, and at the same time the second instruments also further classified indicating instruments, recording instruments and integrating instruments. What do you mean by the indicating instruments? This indicates the magnitude of an electrical quantity to be measured on a calibrated scale. Good example is the voltmeter, ammeters, megers. Indicates at that instant. So we already explained speedometer. Whereas the recording instruments, whereas the indicating instruments at that instant indicates the value, and after that, so when we going to the standstill condition, the reading will be 0. But I want the some record on a paper, so that can be overcome here on a recording instrument, which gives a continuous record of the variation of the electrical quantity to be measured. A good example is the ECG and seismograph item, and whereas another is the integrating instruments. So combination of indicating instrument and recording instruments, that means here the which measure the total amount of quantity supplied to a load over a given period. It's a what are the value from given period, from starting to ending, what are the electrical quantity is supplied to the one input to output is cumulative, adding, summing things, and it will give a value at final value for a given period. A good example is the energy meter generally used in our domestic applications, ampere hour meter. Now coming to the what are the essential of indicating instruments. So indicating instruments we have seen. So common essential parts of instruments are, one is the pointer, another is a calibrated scale, another is the jewelry bearings and covers. At the same time, in torque is required, some electrical torque is required. What are the torques in a instrument? So the torques are classified into a deflecting torque, controlling torque and damping torque. The deflecting torque is required to operate the instrument. Controlling torque is required to restoration of the pointer, and damping torque is required to nullify the oscillations at final positions. As we know that the deflecting torque is directly proportional to the effects, that is the energies which is given to our instrument, whether it is a moving coil, a moving iron or dynamometer type meters. Whether you are going to the voltage or current in the form of electromagnetic, magnetic effect, heat effect, static effect, dynamic effect. So, it is directly proportional to the effects. If input is more, deflection torque is produced also more, that is TD is directly proportional to the effects of voltage or current. To restore, to control, to oppose the deflection torque. If deflection torque is produced itself, it will overshoot the pointer, sometimes exceed the full scale deflection also. And when there is no effects input, then pointer has to come to 0 position, that is restored the pointer to the 0 position for the next operation. That purpose we require the controlling torques. Without controlling a pointer, it will move indefinitely, and hence controlling torque is required. So, this controlling torque can be produced in the instrument by using two methods. One is the spring control method, another is the gravity control method. In spring control method, we are used the phosphorus branch, a spiral hair springs, or two numbers are used on a spindle. One is spring is wound, unwound, another second spring is twisted, that is connected in opposite directions. One spring always unwind, and the second spring should be twisted, one charged and is the releases. The twisted effect produces controlling the torque. Now, what are the properties required? Already we covered. The phosphorus branch air spring required the following characteristics. What are the characteristics? It should not be magnetic material. That means it is a non-magnetic material. It should not be fatigue. It requires the very low resistance. It should not be corroded, and it should be available, cheap and best, and durable. At the same time, it is also required the very low the temperature coefficient of expansion. These properties required for a spring. So, what are the advantages of this one? So, we will see later. And gravity control already we have seen. So, in gravity control, a small adjustable weight is attached to the spindle, which provides a necessary continuous torque. A small adjustable, that is a weight can be adjusted based on our requirement. So, here the weight is due to the gravitational effects we are taken in consideration. So, what will happen? What are the difference between the spring control and the gravity control? The spring control system, we are used the hair springs, whereas in case of the gravity control, we are used a small balanced weights. Spring control, so we are going to get that the scale is uniform, whereas in the gravity control, scale is not uniform, cramped at starting and ending. Because this is the reason, so controlling torque produced in the gravity control is directly proportional to the sin theta, whereas in spring control, the controlling torque directly proportional to the theta only. In spring control, we can use the instrument at any position while taking the readings, but it is not possible in case of the gravity control. The meter should be always placed in a vertical position only. But the gravity control instrument is a very robust and cheap and best, but whereas the spring control the meters are very delicate and costly, but it can be used for any place. It is a portable and accurate reading will give, whereas gravity control, so it is preferred for panel mounting only, and the reading may not be not accurate. These are the differences we discussed in last class. Now, coming to the after completion of controlling torque, we are going to avoid the oscillations at the final position. That purpose where is the damping torque is required. It is necessary to avoid the oscillations of the moving system about its final deflection. So we require the damping torques. The damping torques can be produced in our instruments by using air friction damping, fluid friction damping, and eddy current damping. So in air friction damping, air is as a medium to nullify the oscillations. Fluid friction damping, a high viscosity fluid is used to nullify the oscillations, and eddy current damping we are going to use some permanent magnet used to nullify the oscillations. This all we are explained clearly in previous classes. At a glance, what is the difference between the air friction damping, liquid friction damping, and eddy current damping? So air friction damping, the air is used as a media, and whereas the liquid friction damping, the high viscosity oil is required the media, and eddy current damping, so permanent magnet is required damping. Now here air friction damping, air is as a medium, simple and cheap, and is effective, and we can use at any position while taking the reading, for taking the reading. Whereas liquid friction damping, here we are high viscosity oil is used, non-corrosive oil, but once oil is used, there is a possible to creeping out. So quantity of the oil may be reduces, then effect may be takes place, and more efficient, and it can be used to only vertical position in case of liquid friction damping, fluid friction damping. Whereas the eddy current damping, the eddy current principle are used here to nullify the oscillations, and is a simple and a very cheap and more effective, and this type of the instrument can be used at any position for taking the readings. So these are the some recaps we have covered previous classes. Okay, now let us see what are the objectives in this class. One is the errors in measuring instrument. The errors are, what are the main errors? Gross error, systematic error, and random error. Now you can see what is the definition of the error. Error is the difference between the actual value and the measured value. So actual value and measured value. The difference should be always, in ideal case, that should be 0. You can see this figure. What is the errors? Type 1 error, you can see false positive. Good example. So this is a male and female. So due to the errors, the results are different. This should not be done in our electrical engineering while you doing measuring the values with the help of instruments. That's why you should require some basic knowledge. Otherwise, you may become just like these doctors. Okay, so what is the difference? The error is a difference between the actual value and a measured value. Now, what do you mean the error? You are the very familiar while doing in computer programming, or you are doing something wrong, automatically the computer will give the error message. That means, so you are doing something error, something misinterpretation, or something you are doing the not in a correct way. Similarly, so in our system also there is a errors. Errors in instruments are further classified into, one is the gross error, another is the systematic error, and another is the random error. So these are the 3 errors in our electrical instruments. So let us see one by one. What do you mean by the gross error? The gross error is nothing but the human errors. Human errors. Here, so wantedly, unwantedly, the person sometimes due to the confusion or they are doing some mistakes on the system, then results the wrong results. And you can see so different persons having the different intensity, and these are the this leads to errors in the system. Now calculation errors human makes while taking readings and recording the value on a instruments on a paper. So instruments sometimes may be shown a wrong reading. The human may be miss observation, or it may be take the reading in, for example, if you take the mister is reading the 21, but so while he taking the right is a 21 2 1, instead of 2 1 he may write the 1 2 12. That may be wrong values. That comes into the gross errors. And sometimes after taking the careful calculations, basic data, so I think you are very familiar in exams. While calculating the exam problem, we are taking the given data, we are taking, but so whatever the given data is given, so one or places we are taking the, instead of the some data we are taking the other data. For example, 10 kilometers per hour, or so in 10 kilometers per hour, instead of we are taking the 10 meters per second, then automatically total calculation will goes to wrong, that calculation error. So here what will happen, if while there is a possible to chances of while reading itself, whether instead of reading the 2 1 you may take the 1 2. So you are going to take the 0 1 0, instead of you take the 1 0 1. Reading itself the problem, and while taking there is a possibility to record on a paper or a logbook, it may be possible to error. And after taking these values, so there is a calculation errors where you are going to apply our method principles, so that may be possible to errors. These all errors are known as a gross errors. So the gross errors, how we are going to nullify these gross errors? So here the careful is required. Careful observations is required while reading the value in an instrument, while taking the reading from the instrument on a paper, and while doing the calculations based on a formulas should be care. So we are going to avoid these gross errors. And second thing, so this can be avoided by performing the more experiment readings. Instead of 1-2 experiment, you do the 5-6 experiments. I think in our laboratory we are also taking the each and every experiment minimum so 5 to 6 readings. By changing the input, same procedure, but we are taking the 5 to 6 readings, and that readings we are going to average, then we are going to get nearly the accurate value. Instead of 1 and 2 reading, it may not be accurate. So for in case of the graph, so we have to take the readings are more than 7, 8, 9, 10 is enough. 10 readings is required for getting a smooth graph. Similarly, here also we can avoid, so we have to perform the experiment number of times. So by changing the variable, we are going to take the readings and average that value. We are going to minimize the error, the gross errors. Now the gross error, here we take the voltmeter. Instead of taking the accurate, here we can see from 0 to 100 there is no scale on this one. So at that what condition you have to take the very careful. Suppose I want the 52 volts, not possible in this case. After 100 to 20, because this is a AC, a cramped at starting, a cramped at ending. So here 0 to 100 volts, we have to take the very careful reading based on the position of the pointer. The distance you have to measure, distance you have to observe 0 to 100. Here you have to take the careful. From 100 to 200 there is no need to measure the value. So simply there is a scale. So this may be possible to some error. That error is known as a gross error. What are the remedies? One is the proper care should be taken while handling this while reading experiment, writing experiment and calculating experiments. Another is by performing more experiments and average the values, then we are going to get the values. Now coming to the second classification of error is the systematic error. What do you mean by the systematic error? Here the systematic error the further classified into instrumental error, environmental error and observational error. So here the classification of static errors are reading errors, that is mainly the parallax error while taking the reading. So parallax error, misreading and instruments, alignment errors. So already you know what is being the parallax error. Now the classification of the static errors and characteristics errors say due to the calibration and inertia effect, drop in voltage, and environmental error say the temperature, loading errors, error due to the elastic deformation due to the support of springs or some materials. I think you have some confusion. Let us see in details. Now this systematic error the further classified into instrument error and environmental error and observational error. What do you mean the instrument error? Let us see. Instrument error. Here you can see that this is the moving coil instrument. Already we have covered here. This instrument consists of U-shaped magnet and it has the one coil. It is placed on an aluminum frame and is placed on the spindle. The spindle is placed on a jewelry bearings and two springs are placed on top and bottom. The spindle is all attached to the pointer. The pointer is moving on a calibrated scale. So these are the different parts. So in any part there is a defect in mounting, defect in installing time, there is a meter will shows the wrong readings. This type of the readings we can say this is known as a constructional defect. Now at the time of the construction itself there is a defects. Sometimes you can see defective items sold by 50% in Flipkarts, in Amazon and big bazaars, at D-marts, big stalls. So they are giving the discounts nearly 40 to 60, 70, 80%. That means small defects. The defects cannot be identified normally. So we can identify those defects by if you observe carefully. So here also some constructional defects and routine defects sometimes and calibrational defects. Okay, now at the time of the construction itself I am very careful. I followed the as given by my supervisor and chart, but so I given to the another section fellow who is going to calibrate this one. Even I am perfect in my manufacturing installing that equipment, and after calibration that section if is negligence there is a possible to total system collapse. calibration means it is a comparing with the absolute instruments. Based on the absolute instruments, our instrument should be calibrated, then it works perfectly. So while construction period or while calibration period, if any defects, that increases the showing of errors while doing in day-to-day life. So this acts as a load on instruments. Then what are the remedy? So what are this one? Generally these are, for example, you can take the friction. Bearings is not perfect, jewelry bearings. There is a some defects. So due to the friction, so load on the spindle, and sometimes there is a hysteresis effect. So due to the material, if you are not using the silicon magnetic material, there is a hysteresis losses may takes place. That act as a load on instrument in addition to the normal load. Sometimes eddy current loss also. The instrument may be heated. These are the unwanted things. So act as this one. So what are the remedy? So we should require the careful while in construction time and calibration time. Okay. So the friction effect and hysteresis effect act as a load on instrument in addition to the actual load to measure the instruments. Okay. So that is a thing. Now coming to the environmental error. So that means the atmosphere, the instrument we are going to use at that place. So this is subjected to the external effects. So that is the weather conditions. If the weather is a humidity, so weather having the high pressure, weather has a temperature, this temperature, pressure, humidity may affect on our instrument while gives the reading. So this type of the errors are known as the environmental errors. The external condition effects on instruments, that may be temperature, humidity and pressure, and sometimes there is a possible to the external electromagnetic field or electrostatic field also affect on reading of instrument. So this type of the errors are known as the environmental errors. What are the remedy? Now what is the remedy? Maintain a constant temperature and humidity in that location where you are going to measure the values. So in case of the laboratory, you have to maintain the constant. What is the temperature, humidity and pressure in that room? So it will give a reading every time is accurate. Otherwise, if temperature changes, automatically the value may be varied from previous value. And avoid external magnetic field effect on the instrument. So where you are going to measure the variable value, so nearby that place you have to better to avoid the external magnetic materials or magnets or something, and then you are going to get the accurate reading. Now coming to the another is the observational error. What is the observational error? Here the wrong observations. Now meter is giving the perfect value, but while taking the readings, while observing the readings, we take in the wrong observations. And at the same time, another is a parallax error. As you know that parallax error. So what is the, here you can see while using the this reader, due to the suppose damping torque is not perfect, then what will happen? The pointer will fluctuates, oscillates at final position. So instead of stable, it is a overshoot, undershoot. At that condition, so we have to wait. Still it is stable, we have to take the reading. Otherwise, what will happen? Approximate value we are going to record without waiting. So that may leads to error. A parallax error. What do you mean the parallax error? So as you know this, so instead of here, you have to stand nearly 90 degrees it's in phase with the pointer, that will gives the accurate value. So instead of here 30, so sometimes we will take the reading instead of here, what is the value? 30.32 instead of 32. So sometimes we are by negligence we are taking the approximately 30 value, because so the person is standing this side, then automatically it will near to the 30, so we will take the reading, but it is actually 32. That may leads to wrong. And sometimes we can say here power factor meter, so it's showing the reading this either side 0.9, 0.9, 0.7, 0.7, 0.5, 0.5, but you have to take the reading whether it's a leading or lagging that side, so you have to note that thing. Otherwise it's showing the 0.7 lead, but you are taking the 0.7 lag, so automatically total system collapse. And sometimes there is a two arrows, so a reference and another this one. So instead of taking the other, you are taking the another one. In MD meters, maximum demand meters, generally installed in small industries. So for the calculation of current bill tariff, so there is a two pointers. So you have to take the which is a reference, which is a normal moving. So these are the possible errors while observing these readings. Now, so parallax error, you can see a parallax error is an error in reading an instrument due to the eye of the observer and pointer are not in a line perpendicular to the plane of the scale. So this is a definition already you learned in a school level. What do you mean by this one? This is a scale. So here we used this one. So there is a three possibilities you can see in the figure. A parallax error is an error in reading an instrument due to the eye of the observer and pointer are not in a line perpendicular to the plane of the scale. You can see this is a center eye and right side eye and left side eye. So left side also incorrect and right side also incorrect, whereas the correct is the middle eye. At that condition we have to take the reading. So you can see here the line 91.50 centimeters along, not 92.10 or 90.90 centimeters. So this is known as a parallax errors. So how to overcome this one? The parallax error occurs when the measurement of an object's length is more or less than the true length. Now how we are going to avoid this one? The parallax error remedy is the arrangement of mirror glass in instruments. For example, in our laboratory you can observe this is a one instrument voltmeter. Here there is a glass, you can observe here. Now so this is a glass. So in that glass you have to see the reading. It avoids the parallax error. So this is the one glass is placed here. So by seeing that the pointer should be see in the glass, then it will avoid the error. Okay, so this is the already you know this thing. Now another error is the last error is the random error. Now we have seen the gross error and systematic errors. Then systematic errors, the instrumental error, environmental error and observational error. But last one is the random error. What is mean of the random error? Random error is nothing after calculating all systematic errors, even then few known and few unknown errors may found while using the instruments. After careful observations, careful everything, then there is a sometimes we are going to unpredictable errors maybe takes place. These unpredictable errors are known as random errors. Random means at any time, at anywhere, maybe errors occurs. This known as a random errors. Okay. Now if you measure the weight of a ring, suppose you have the ring, suppose you have the small ring in your for your ring with your fingers, diamond ring for example. If you measure a weight of the diamond ring with the same balance in different times, then you may get the 15.23 grams, 15.21 grams, 15.22 grams. That means, so what is the effects? So we cannot avoid, sometimes it will show. So this type of the errors are known as the random errors. That's why in jewelry persons, they are measured these values in a glassed weighing machine. That means the pressure, sometimes you can observe in the fan air also impact on the gold weightage. So they will stop the fan, otherwise the air also forces the some grams, milligrams. So they will measure in a glass chamber or vessel. Now you can see here the errors, random errors. Error may be occurred. Here in this case our instrument, this is a moving coil instruments, moving coil instruments. Here what will happen? The air friction damping is used here. After usage of air friction, so there is a wear and tear takes place in piston head and cylinder. There is the suction and pressure developed in the air friction may not be equal, it may be deteriorates. Then the controlling torque decreases. Or so we have the coil, copper coil on the this is a armature. The copper, after using them so many years, the copper coil also weakens its stability and strength. Then it may not produce that much of the flux at initially. Initially it may be produce a good amount of the flux. After weakening using that one, is a property changes, because when after using so many times there is a heat is developed due to the property changes. When property changes, temperature changes, and the resistive value changes and alpha changes. Due to this one, it may not be able to produce the same flux. Due to the change in flux, the reading also changes. So how we are going to avoid this one? We cannot avoid. So then if it is a problem is very serious, then we are going to once again recalibrate the instruments. That is the remedy. Now intake in the fluid friction damping. Suppose the fluid, which is the high viscosity oil, leaks, then automatically the damping power may be changes. And now you can see that in case of the moving coil instruments, here we are using the horseshoe magnet. Horseshoe magnet, permanent magnet, as we know that the magnet power may changes due to the aging. At initially the power permanent magnet has a good intensity, strength. After using some years, what will happen? Due to the temperature effect, due to the some mechanical defects, then its magnetic field may be reduces. Then what will happen? The permanent field may not be as much as starting. Then the whatever the electromagnetic field, this field may not give the accurate reading. Some values changes. That is the leads to random error. At the same time, you can observe the springs also. Here phosphorus branch hair springs are used. The springs after using so many years, what will happen? The fatigue takes place. The tension in the springs may be changes. Then reading may be changes. So all possible. So here you can eddy current damping. So here we are using the permanent magnet. The permanent magnet means after using so many years, its magnetic field decreases. Then here what will happen? The damping effect decreases. That leads to error. So that error is known as a random errors. We cannot avoid this type of the errors. These are the inherent errors. These errors are known as the random errors. Now compare this between the systematic error and random error. So we know the gross errors are human errors during the reading, writing and calculations. Taken out that careful way is required. And coming to the the systematic error and random errors. The systematic errors are instrument errors, environmental errors and observational errors. Now, here what is the main difference between the systematic errors and the random errors? The systematic error, the repetitive in nature. What is the error? Repetition takes place, whereas random error, random in nature. So, whether it may be occurred, may not be occurred. The value may be changes at different places, different times. And systematic error results from improper conditions and procedures. The procedure may not be same, automatically the value changes. Conditions, the temperature, humidity, pressure and a side external effect of electrostatic field, electromagnetic field, we don't know the things, we cannot observe, but maybe changes, then automatically output also changes. But whereas in a random error, these errors are inherent in the measuring system, we cannot avoid. And systematic error, they controlled in a magnitude and sense. Whatever the errors, if possible, we can control. In magnitude, error may be reduces, and senses, there may be changes. But in random error, they are accidental in nature and difficult to control. So, what is the reason for this problem? We cannot identify first of all. So, if you don't know problem, how we are going to make the solutions in case of random errors? So, but random error is a very minimum as compared to the other errors. By proper analysis, these errors can be reduced and eliminated in case of the systematic error. But so in random error, so we cannot eliminate. The statistical methods does not apply on error, but it can be applied on random errors, theoretical. Good example of systematic errors are parallax errors and calibration errors. Here, the random error can be reduced by slight displacement of measuring joint between the joint to joint, the friction. The friction of the mating parts, by changing, we are going to somewhat maybe changes. These are the some comparison between the systematic error and random error. I think you have some idea on errors on instruments. Now, let us summarize what we have seen in this class. We have seen all from starting to ending what we have studied in previous classes, basics. Now, in this class we have seen errors regarding the what do you mean with the error definition, the errors in measuring instruments, that may be gross error, systematic error, and systematic error further is the instrumental error, environmental error and observational error and the random errors. So, what are the reasons, what are the causes and what are the remedies we have seen. Okay. So, these are the some few points, basic points regarding to the errors in our electrical measuring instruments. So, I think you have some idea this one. Thank you for listening my class.